So here are the two objectives regarding the oscillation. In the first objective, it explains that you have to calculate the time to move an object from mean to half of its amplitude. It means that let's suppose we have any oscillation system, like we have mass spring system. We have a spring and a mass attached with the spring. Okay, so this one is a mass attached with the spring, and this is a mean position of this mass. So we have to displace that mass at extreme position. When the mass is displaced at extreme position, it has a displacement represented as x naught, called the amplitude. So we have to calculate the time in which this mass is covering a distance which is equal to half of its amplitude. Let's suppose that half of amplitude comes here, so we have to count this time x naught divided by 2. That is half of amplitude, and we have to calculate the time from the mean position, not from the extreme position. Okay, so we have to calculate from mean position. So the equation for displacement is x is equal to x naught, and it becomes sine omega into t. Remember this one, that when a question is given through the mean position, we must use here a sine function. So x is given, which is half of its amplitude. So x is represented as x naught divided by 2, which is equal to x naught and sine of omega into t. And the value of omega is 2 pi divided by capital T, and multiply by this given time which you have to determine. This capital T is a time period. Now x naught get cancelled. Sine comes here, becomes sine inverse. So it becomes sine inverse and 1 over 2. And it equals to 2 pi divided by capital T and multiply by small t. So sine inverse 1 over 2 is 30 degree, and 30 degree become pi by 6. So here we have to put pi by 6 is equal to 2 pi divided by capital T and multiply by decimal t. Pi get cancelled. Okay, and we have to calculate the small t here. So 2 comes here and capital T goes there. So small t becomes t divided by 6 multiply by 2 becomes 12. So that is a given time in which the mass covering a distance is equal to half of the amplitude. But remember this one, that the body must be start from mean position. Okay, now moving towards another MCQs in the same pattern. In this MCQs we have to calculate again the time, but in this part the particle or the mass starts from extreme and covering half of its amplitude. So first we have to put here an equation. It's starting from extreme position, not mean position. So we have to use here the cosine function. So x is equal to x naught and cos of omega into t. So put the values, x become x naught divided by 2 because it is again half of the amplitude, and it equals to x naught cos of omega into t, and the value of omega becomes 2 pi divided by t into small t. X naught get cancelled. Cos comes here in inverse formation, so it becomes cos inverse 1 over 2, which is equal to 2 pi divided by capital T and multiply by the small t, which is a given time. Capital T is a time period. Cos inverse 1 upon 2 is 60, which is pi over 3. It becomes pi over 3 here. So we have to put here pi over 3, which is equal to 2 pi divided by capital T and multiply by this small t. So this pi get cancelled, t comes there and 2 comes here in denominator. So small t becomes capital T divided by 2 multiply by 3 becomes 6. So small t here becomes t by 6. So in the case when particular mass move from extreme position, we have to use this equation. And in the case when particular mass starts from mean position, we have to use this equation.